Hello friends, in the last session we have seen the lambda expression with parameters, and we have seen without parameter or one parameter, or when you have multiple parameters in lambda expression, how will you write. Now in this session we are going to see lambda expressions with return types. So take a test. It's a test 1 in package P5, and I have an interface, my interface, and a method, so return type is int, and show is the method, right? No parameter, right? Just return type. So if I want to write a lambda expression for this, now my interface, say my in1 is assignment operator and no parameters or default empty parenthesis and this, and it has to just return 10, right? That's it. Or you can say it is return 10. Write a termination. Okay, fine. Now when you the function, this is the function implementation, this is the show function implementation in this, and now when you will call the function here, my interface 1 dot show, and it returns a value. So I am storing that in integer type, and it is int result is equal to, and you just print the result and check result is 10. Result is 10, right? This is the function call. This is the function implementation, lambda expression, right? This is the lambda expression, this is the function implementation, and the implementation you are storing into this reference variable and calling the function. When you are calling the function, after calling the function is having a return type which is int, and it is returning 10, and 10 I am storing into this result and printing it, right? Now I can take something like this also, say my interface, my in2 is equal to, this is the implementation, and return say 99, return 99, and you have to give the block notation what is return, or it is having, I'll write it has multiple statements, so I'm writing the block notation, and it is this show function is called, and then it has to return 99, right? Then it has to return 99. So now the function implementation is till this. Now in this my interface 2 dot show, when you will call and run it, show is called and return value is not stored actually, so it is again result is equal to this, and print the result also. Show function is called and result should be 99, this, right? Now if I have another interface, say interface in1 is this, and it has a function which returns a string value actually, so this is string, and the function name is some m is the function name. Okay, this is the interface. For this, now you have to give the implementation here with a lambda expression. So in1 is equal to not new, it is this, and it has to return a string value, so return some high, and this, right? This is the function implementation done with lambda expression. Now when we'll say in1 dot m, it should return a string value, and I'm storing string s is equal to, and print the s, right? Run it, it is printing, returning high. Or I have another interface in2, which is having return type int, method is m, it is having two argument int x and int y, right? This is the interface, and this implementation I have to give here now, and it is interface 2, and this is it. Now here draw a line and you give so this is interface 2, and implementation of the lambda expression is in2 is, but it has two arguments, say a and b, and it has to return a greater than b, or return, take a greater than b conditional expression, and this is ternary operator, right? This. Now we missed this, so it is now okay. And if I write it like this, say int some I is equal to in2 dot m of 10 and 20 and print I, it is to give which one is greater, right? If this ternary operator condition is to evaluate it, and it is to give the result, so the result should be here 20, right? It is printing 20. Or again, if I call the same function again, say int j is equal to in2 dot m with some 99 and it is 33. Now if I print j and run it, it is 99, right? So this is one with return type. Or if I say something like this, say interface in3, and which is having return type is int, and method name is some m, taking a string type argument s. And now for this lambda expression, implementation is this, right? And now say in3 is equal to, argument is there, so I'll take it as a, and it has a return type, so return a dot length, because it is string type. I want to get the length, and get it, say int length length 1 is equal to in3 dot m, and give here hello, and get the length, print it length 1, right? On that length 1 hello is 5. Or again, if I call the function, say int length 2 is in3 dot m of, say it is Java, and print the length 2 and run it, this is length 4, right? So this is the return type of this function. Or I'll take one more interface, say interface in4, and it is a method get instance in the function, and it has to return actually an object of type abc, and abc should be a class somewhere, say class abc, right? It has to return this abc object, and after getting that object, I'll call, or I'll just print abc, okay? So to write the expression now for this interface is and you write in4 is no argument in that, and this return new abc, right? And this is the function. Now when I'll call in4 dot get instance, it gives an object of type ABC, and I'll store it ABC A1 is equal to, and print that A1 right, and run it. It is okay, this it is ABC type object. Or I'll take here a default constructor, say ABC int A, sorry, ABC, just default constructor it is, and I'll write here it is ABC default constructor called, right. Now if I run this is creating an instance by using default constructors. Will print that, and after that here you are getting the object. Run it, it is fine, ABC default constructor, right. So this is the implementation, this lambda expression is the implementation of the method of interface this, right. Or if I take another interface in5, which is having a method, return type is object, and the method name is some name, say this is the method, or get object something, right. This is the method now. So this can return anything because the return type is object. And if I make it like this and say it is in5 is this, no parameter in that, so it is this, and it has to return any object. So first time it is returning, say, some ABC string type object. Now when you call this function, you get here the string s3 or s5 is equal to in5 dot call the function get object and print s5. Run this. Okay, it is returning by default object type, so you can write here typecast that to string, right, typecast to string. Run it, it is fine. Okay, it is fine. Next, if I write same another one, say in5 and in5, so this in6 is this, and return say 10. Okay, this is returning 10. Now if you call say int ab is equal to in6 dot get object of this, and this is returning again object, you cannot store into this integer type. So what you have to do is, or you typecast to it, right, print it ab and run it, it is fine. So this is return type with lambda expression. Or if I take a lambda expression with some generalized type, say interface in6 with some generics, some t, right, and then return type is t and function name is get t, right. This is generalized type. Now when I'll implement this, instead of doing this much typecasting here every time, I can use generics directly, and then I'm using say in6 or it is 7, actually it is, say this, and it has to return something, return say 99, but I have not used generics here, so I need to use generics at this point. So it is integer, right. Now it is returning integer. I can directly get here, and I'll say int xy is in7 dot get t, and you're directly getting int, you no need to typecast xy, right. Run it, you're directly getting in type, no need to typecast like previous. Or if I take another one, say in6, and this is of type string, and this is in8 is equal to say, and it has to return something, return say string type, so high, returning high, right. and then I'll call string s8 is in8.getT, and it is printing s8. Run it. It is fine, right? It is fine. Or I'm having a function with return type and with argument also. So interface in7, and this has a function. Return type is int, function name is am, taking an argument of type int also, right? And if I write here now, draw a line, and you can say just a in7, in9 is argument, only one argument, right? So I'm just writing directly like this, and then return a. Actually, yes, right, it is in7. in7, and it is returning 8 still directly, and I'm not using here parenthesis because it is only one argument, and I can call sy print in9 dot m is the function, and 99, and it is printing directly 99. Run it. It is fine. So this is the return type of lambda expression, right? This many ways you can use a return type for a lambda expression. So in the next session we're going to see lambda expression as a method argument, right? And in this we have seen the lambda expression return type. Thanks for watching my video. Please subscribe for more videos.